This is part 2 of the topic test 5's review, similarity, and trigonometry. All right, number 1. So in this type of problem where you have a right triangle around the outside and you drop an altitude from the 90-degree angle down to the hypotenuse and forming 2 more right angles and 2 more right triangles. We derived these 3 equations in class a while back. They were a squared is equal to c times ca, b squared is equal to c times cb, and h squared is equal to ca times cb. C refers to the hypotenuse of the original large triangle. Okay, and then A and B we can label on either side, A or B. But once we make that choice of A or B, then these other variables, CA and CB, they should correspond to whatever side you chose to make A and B. So if you made the left side of the triangle A, then this bottom portion here from K to N, that'll be CA. Since A is on the left, you put CA on the left. And then on the right hand side, you're gonna have CB. Okay, so let's go ahead and figure out which equation is gonna be useful for us this time. They're telling us that Kn is equal to 7. Kn is just the left bottom side over here, Ca. And Ln is 5, which is the height. Okay, since they gave us the height, the only relevant equation is going to be this one. So let's go ahead and write that equation. H squared is equal to Ca times Cb. H is 5. Ca is 7. And Cb is unknown. And CB is what they're looking for. So it says, what is Mn up here? And that's what they're looking for. On these IXL questions, the pattern was very clear. They're always looking for the one that's missing in one of these equations. Okay, so then 5 squared is 25. 7 times CB on the right. And then divide both sides by 7. That cancels out, and you get CB is equal to, you got to type it into your calculator because they want you to round. So 25 divided by 7 is 3.57, rounded to the nearest hundredth. So you type in 3.57 on Edge Elastic. Okay, next question. I'm going to go pretty fast through these because it's the same thing over and over again. And I'm a little bit pressed for time. So I'm not going to rewrite the formulas every single time. I'm just going to go ahead and pick the right one. So they gave us Km, which is C. And they said it's 30. Mn is 12. Okay, so let's say I label this A and B. So they gave us CB and C, and they're looking for Lm, which is B up here. Okay, so the correct equation is going to be B squared is equal to C times CB. B squared, we don't know what B is, that's the unknown. C is 30. CB is 12. So B squared is equal to 360. And then we got to take the square root of both sides to isolate B. And the square root of 360 is 18.97, rounded to the nearest hundredth. Okay, next. All right, they're telling us EF is 19. Let's call this A. EH is 11. We'll call that CA. And they're looking for EG, which is the entire bottom side, which is C. Okay, so the correct equation is going to be A squared is equal to C times C sub B. A is 19, so I'll plug that in. 18 squared is equal to C, we don't know, and CA, sorry, that was a mistake. This should have been CA up here. CA is 11. So we got C times 11. 19 squared is 361. So 361 is equal to 11C. Divide both sides by 11. This cancels out. 361 divided by 11 is equal to 32.82. Okay, next question. Number 4. They give us WY, which is the entire bottom part. C is 12. WZ is 4. And since I'm going to label this side A, this will be CA. And they're looking for WX, which is side A. So we're going to use the equation A squared is equal to C times CA. A we don't know. C is 12 and CA is 4. So you multiply these two and we get 48. Take the square root and we get A is equal to, plug it into the calculator, 48 square root, 6.93. Okay, next question. Number 5. They gave us PS, which is 9. We'll call this side A, so this will be CA. RS, which is this part, is 34. That's not the entire bottom. So this side will be B, this will be CB down here. And they're looking for QS, which is the height. So the equation we're going to use is the one that has a height. H squared is equal to CA times CB. H is unknown. CA is 9. CB is 34. 34 times 9 on the calculator is 306. And then we got to take the square root. Whoops. So H is equal to 17.49. All right, number 6. Okay, number 6 and 7 are a bit different. These review what's called the triangle proportionality theorem. Now, whenever we would write a proportion between the sides of a triangle, it had to be between, well, it had to be between the corresponding sides. So, for example, if I have triangle ABC, and let's say this was 10, and let's say A was 5, and then let's say we have another triangle that's similar, larger, or dilated, right? All those things are related. And let's say this was 20, and we needed to find out, well, so I shouldn't call this B, because it's a different triangle. Let's call this ABC. We'll call this side D, E, F. And let's say that we're asking for side D. Okay, so you guys can probably tell that the big triangle down here is twice as big as the triangle at the top. Because that's how we would get a 20 down here, if you took 10 and multiplied it by 2. So you can already tell that the scale factor is 2. So you probably already know that you just have to multiply the 5 times 2 to figure out what D is. But what I just want to emphasize the way we write the proportions. So the way I always like to write it is I like to set up the proportion first with what I'm looking for. So I'm looking for D, so I go ahead and set up my proportion with D on top. And then what we do is we go look at the other triangle and see what side corresponds with D. So the side that corresponds with D, but for the little triangle, is this one, side A. So we would write D over A equals, okay, then we come back to the big triangle and look for whatever information we have. We know that E is 20, so then we would plug 20 on top, and then figure out what corresponds to 20, but in the small triangle, which would be this bottom part here. So we plug in 10 there. And I plugged in an A down here by mistake. Sorry, this should have been a 5. Because that's the length of that side at the top. And then, like this, we'd solve the proportion. So just notice that what we do is we figure out what sides correspond to each other. What entire sides correspond to each other. Now, what's interesting about the triangle proportionality theorem is that it turns out you're not limited to figuring out which sides of the triangles correspond to each other. You can also correspond like partial portions of the triangle. So let me just erase all this and identify what partial portions I'm talking about. So for example, there's two triangles in this picture. There's the large one around the outside, which is X, Z, V. And then there's the smaller one on the inside, which is X, Y, W. Now, when we first started doing similarity, you had to make sure that you set up the proportion between the entire side of the triangle, right? So I would have to say that 30 over 45, and the reason I can do that is because 30 is this entire side of the small triangle, and 45 is the entire side of the big triangle. So I'm actually finding corresponding sides of the triangle. And then I can set that equal to the other side of the triangle. But with the triangle proportionality theorem, we're not limited to just doing the entire side. We can actually take advantage of just certain parts of the sides. So, well, before we do anything, this right here, YZ, that is equal to 15. And the reason for that is because if this entire distance is 45 and you've already spent 30 from here to here, then that means that there's got to be 15 left for this bottom part. You just do 45 minus 30. Okay. So what you can do is you can set up a proportion between just the partial sides. So if we know this is 15, then we could do, well, actually, hold on. I'm going to be consistent with the way that I like to do it. So we're looking for WX. WX is up here, right? So I like to put what I'm looking for first, so WX. So what you can do is you can say that WX corresponds to this side. So WX over 30 should be equal to the ratio between this leftover portion. It's not even an entire side of a triangle. 12, the ratio between 12 and 15, this other remaining portion down here. So this was the big deal about the triangle proportionality theorem. All right, so you multiply this side by 30, this cancels out, and you multiply this side by 30, and you got WX is equal to 4/5. So 24. Well, let me just do the math. So 30 over 1, the 15 and the 30 can simplify. So we end up with 12 times 2 on the top. So we got 24. Okay. Last one. So, question 7. Again, you don't have to relate entire portions of the triangle. So it says GI, we're looking for GI. Okay, so GI is this entire side. Okay, this portion right here from j to I is 39 minus 13, which is 26. Because the whole thing's 39, and there's 13 from here to here. Okay, so what we can do is we can figure out what hj is, and once we do that, we can just add it to 19. So we can do, and we're going to use the triangle proportionality theorem. So we're going to write a proportion where we're not even comparing entire sides. So we're going to do hj is to 26 as 19 is to 13. Okay, so let's go ahead and solve for hj. So we're going to multiply this side by 26. This cancels out. Multiply this side by 26. hj is going to be equal to, the 13 and the 26 can simplify. So we got 1 and 2. And we end up getting 38 on the top. 38 over 1, which is 38. So hj, the hj portion by itself is 38. And to figure out the entire gi, we're just going to add 38 plus 19. So 38 plus 19 is equal to 57. Okay, that's it for that one. And that's it for this part 2